Hello, future doctors. Welcome back to our chemistry series for Neet 2025 and 2026. I'm Jongtham David, and I'm thrilled to have you here for the sixth episode of our journey. In this session, we'll dive into the essential chapter of hydrocarbons, solving 45 important questions that will sharpen your problem solving skills and deepen your understanding. So stay focused, stay consistent, and keep pushing forward. Your dream is within reach. As Henry Ford once said, whether you think you can or you think you can't, you are right. So believe in yourself and let's make chemistry your strength. Let's see the questions. Question number one, I'll read it out for you. It says, when neopentyl bromide is subjected to Wurtz reaction, the product form is 2244 tetramethylhexane, 2244 tetramethylpentane, 2255 tetramethylhexane, 2233 tetramethylhexane. So to answer the question, let us write down the structure of this neopentyl bromide. It will adopt the structure as shown in the screen. I will write the structure for you. CH2Br. Now for Wurtz reaction to take place, you need to add this sodium metal, react with another mole of neopentyl bromide. Wurtz reaction will take place here. And in the presence of ether, which is your solvent, there will be removal of this salt, sodium bromide. This will go as byproduct. So remove this bromine and sodium as salt, 2 moles of sodium bromide, and the product will be the formation of 2255 tetramethylhexane. So you have to undergo condensation. You can link these two structure so as to get the final structure of 22. I shall write the structure in bond line notation. Okay, 2 carbon here, and this is the structure of 2255, because when you do the counting, this is carbon number 1, carbon number 2, 3, 4, 5, and 6. So 2255 tetramethylhexane. Let us move to question number 2. The conversion of 2,3-dibromobutane to 2-butene with zinc and alcohol is. Let us write the reaction. You are given 2,3-dibromobutane. So this is the formula for 2,3-dibromobutane. Now when this reacts with zinc in alcohol, the product will be alkene. The name of this alkene will be butene. So since 2 bromine atoms are lost from different carbon, the reaction is known as beta elimination. So C is the answer for question number 2. Question number 3. 1,3-butadiene when treated with bromine gives. So the intermediate will be formed here, and by showing the resonating structure, you can draw the secondary carbocation as such. Okay, this is your butadiene, which I'm going to draw. The given butadienes 1, 3. So in carbon number 1, you have double bond 1,3-butadiene. React this with this C. When this undergoes heterolysis, it gives 2 ion bromonium bromide ion. So electrophilic reaction can take place. Formation of intermediate Br and a carbocation is generated here plus CH, CH2. Clear? Now, in a reversible step, this will give rise, it will generate another carbocation, bromine, carbon double bond, CH, CH2. Now, if another Br minus reacts with this, the product will be another alkene, CH2Br, CH double bond, CH, CH2. Yeah, so you can name this. The formula for this compound, the name will be 1,4-dibromo-2-butene. Option A will be the answer for question number 3. Let's see question number 4. Let us read together. An alkene having molecular formula C7H14 was subjected to ozonolysis in the presence of zinc dust. Equimolar amount of acetone and butanone are obtained. So you have to find the starting material. What is the name of that alkene? So this is one common question asked in your NEET exam, finding of the alkene. So we have to start with the carbonyl in order to predict the alkene. So as question says, you have two different types of ketone. Here you have propanone and butanone. So there must be some bridging between these two carbonyl carbon. So likely the alkene must be, I will write in the bond line notation. And this must be the formula of the alkene. This will be called 2,3-dimethyl-2-pentene. So in the option you have 2,3-dimethyl-pentene. So D will be the answer for question number 4. Question number 5. An acid catalyzed reaction hydration of alkane except ethene leads to the formation of. In the acid catalyzed hydration, unsymmetrical alkene, if it is present from the water, the hydroxy group, that is the negative part of the addendum that becomes hydroxide, will goes to the carbon with less number of hydrogen. That is called Markovnikov's rule of addition. So the addendum, if it is dissociated in acids such as sulfuric acid, negative part of the addendum, you have to check at this saturation carbon where there is double bond. In this unsaturated system, negative part of the addendum will go to carbon with less number of hydrogen. So the major product will be a secondary alcohol. Right, this is secondary alcohol. Except ethene, it leads to the formation of. So let us check some more ethene. Let us take a bronze type of alkene for better understanding. I'll give you some more example. This is your 2-methyl prop 1-ene. So when acid catalyzed hydration take place in the presence of sulfuric acid, when this reacts with water, now you will you apply the same concept, Markovnikov's rule of addition. Negative part of the addendum will go to carbon with less number of hydrogen. So basically by applying that rule, you have here tertiary alcohol. So secondary alcohol or tertiary is the ultimate product. Right, so the answer for question number 5 will be option C. Question number 6, let's read. In the reaction of ethene, a hypochlorous acid, that is HOCl, gives M, and R, if it is treated with M, gives ethylene glycol. So you are asked to find what is M, what is R. So when this ethene reacts with hypochlorous acid, you know the formula of hypochlorous acid is HOCl. Okay, so it gives CH2. Here you have OH and a chlorine. Further react this with R. So likely R must be a bicarbonate. Sodium bicarbonate when treated with this M will give your ethylene glycol. Okay, so answer for question number 6 will be B. Question number 7. The negative part of the addendum goes to the carbon with less number of hydrogen. This is called Marconi-Kos rule. Question number 9. 8 is simple. Let's see question number 7 is simple. 8. Let's see question number 8. You have to match the correct answer. Column 1 with column 2. So if you check carefully, A, this is hydrogenation of alkyne, and you have to apply this hydrogenation of alkyne gives alkene. So this will take place with one of the following reagents given in column number 2. So read carefully, this will take place in Lindlar's catalyst or palladium in carbon, and B will take place in alcoholic potassium hydroxide. C from this geminal vicinal dihalide to alkene. This takes place via the presence of zinc, and ethanol gives ethene. This is acid catalyzed hydration. So when you link this, you have A3B4C1D2. Answer will be option A. Fine. Excuse me. Let's read question number 8. Which of the following will yield a mixture of 2-chlorobutene and 3-chlorobutene on treatment with hydrochloric acid? So 2-chlorobutene and 3-chlorobutene. The alkene from the option must be, excuse me, A, because in the presence of hydrochloric acid, you have proton, and this will generate a carbocation like this. Okay, this hydrogen will go to more number of, and this is again Marconi-Kos rule of addition. Or another product may be CH2 double bond CH CH CO3. So when you add chlorine to this compound, it can either come at this carbon number 2 or carbon number 3. Counting starts from the double bond. So 2-chlorobutene or 3-chlorobutene is the ultimate product from this alkenes. Okay. Question number 10, let's read. Lindlar's catalyst is, this is concept question. Question number 9, question number 10, Lindlar's catalyst will be palladium and barium sulfate. Option C. Let's read question number 11. The treatment of Grignard reagent with butane produces methane gas. You can write the reaction for this. We have done this in the first episode while learning haloalkanes, haloarenes. So this is your methyl magnesium hydride. Treat this with your alkyne. There you have your adduct, call it addition product, plus gas which is released. This is called methane. So D is the answer for question 11. Now let's move on to question number 12. A group which deactivates the benzene ring towards electrophilic substitution, but that which directs the incoming group principally to the ortho and para position is. Remember, chloro is ortho-para directing in nature due to the positive resonance plus R effect. However, it is deactivating due to strong minus inductive effect. Inductive effect, as you know, it takes electron. Now, the net result then is that the chlorobenzene undergoes orthopera directing with difficulty. So 12 will be option D, B, chlorine. This is the answer for question number 12. I hope it's clear. Let's move on to question number 13. Isopropyl alcohol is obtained by reacting with which of the following alkenes with the concentrated sulfuric acid and water? So you're given A, ethylene, B, propylene, 2-methylpropene, and D, isoprene. So to understand this, you can write down the reaction. You have alkene, which is your unsymmetrical alkene. When you add the addendum, usually water, negative part of the addendum goes to carbon with less number of hydrogen. This is Markovnikov's rule. In the initial equations, we have seen that it forms a tertiary alcohol. Right, this is your propane 2-ol. Isopropyl alcohol is another name for this propane 2-ol, common name. Right, so the answer for this will be, it starts from propene. So answer will be B. The other name of propene is propylene. Okay, good. Let's move to question number 14. This is a statement type of question, very lengthy. You can read fast. In the preparation of alkanes from hydrogenation of alkenes and alkynes, finely divided catalysts are used. Which of the following statements are correct regarding this catalyst? So, in the first statement, read carefully. Palladium and platinum, they catalyze at room temperature. Nickel catalyze the reaction at a higher temperature and pressure. Platinum and palladium at a higher temperature. So, one is correct. Platinum and palladium, they catalyze at room temperature, no doubt. This is correct. Nickel catalyze the reaction at relatively higher temperature. So this two will be correct answer, because as in dihydrogen gas, when they add to alkanes and alkynes in the presence of finely divided catalysts such as platinum, palladium, or nickel, it forms alkenes. Hydrogenation of alkynes give alkene back to alkanes. Okay, so 1 and 2 will be correct. And further, these metals adsorb on the surface of this metal. Dihydrogen gas will be adsorbed and it starts to activate the hydrogen bond. Okay, so if 1 and 2 will be correct, B will be the answer for question number 14. Remember, platinum and palladium, they catalyze the reaction at room temperature, but relatively at a higher temperature and pressure required with the nickel as catalyst. Now, question number 15. Which of the following is expected to readily give hydrocarbon in good yield? Let us see the options. Potassium salt of carboxylic acid, silver salt of carboxylic acid, ethane, then you have a tertiary haloalkane. See, in the electrolysis of a concentrated aqueous solution of either sodium or potassium salts of saturated non-carboxylic acids, it yields higher alkane at the anode. So potassium will go in the cathode. It now reacts by gaining two electrons, and it gets reduce to potassium. And this potassium will again react with water and form potassium hydroxide. Whereas in the case of anode, carbon dioxide gas will be released along with alkane. Okay, so you can understand this much better by writing the reaction at the anode. Remember, anode is where oxidation takes place. Oxidation, as you know, is losing of electron. The carboxylate ion will lose electron, and from this it will give alkane plus carbon dioxide. Whereas in the cathode, potassium will be reduced. So the correct answer will be A. Let's see question number 16. Which of the following changes is correct? So ethane in the presence of silver salt and iodine changing to uh, diol. This is the first option. Second option, you have the same condition, but the acetic acid given to you is dry. So both A and B, they are correct. So C is the answer for question 16. C. Question number 17. The products obtained via oxymercuration of butane, 1-butane would be, oxymercuration leads to hydration according to Markovnikov's rule, and specially it is designed for alkynes. So let us bring up an alkyne, an unsymmetrical alkyne. For simplicity's sake, I'm giving here butane, and according to the question, it is also mentioning butane. Let us add this reagent, mercury sulfate and sulfuric acid. So when these two are added, you will form an intermediate. This is your alkenol because it has a double bond, and there it will undergo tautomerization and it forms a ketone. So can you name this ketone? This ketone is called butanone. Okay, A will be the answer for 17. Question number 18. The number of optically active products obtained from the complete ozonolysis of the given compound is. So when this ozonolysis takes place, this is a stereoisomer. It is written in the form of uh, isomers. One is chiral, another one is achiral. So when this alkene is made to undergo ozonolysis, you have to check at this branch. When it undergoes ozonolysis by addition of ozone, it gives you 2 moles of a chiral compound. You can name this. This is your acetaldehyde. This is achiral. And in another case, you have 2 moles of another achiral compound, CH, CH3, CH, double bond oxygen. So both are optically inactive. Both are achiral. So it will be 0. Question number 19, let's read. The propyne on polymerization gives. Propyne on polymerization gives. So it will start to undergo cyclization. Propyne, this is your propene, alkyne, okay, with the formula CH3, C double bond, CH. So cyclization will take place, double bond here, H, C. Okay, let us write this ring structure, double bond, CH3, CH. So you can name this. The IUPAC name must be 135 because you start count from here. 1, 2, 3. Okay. 135 trimethyl benzene. The common name will be called mesitylene. So A is the answer for question number 19. Question number 20. The electrophilic substitution reaction of benzene takes place via the following. So according to experimental evidence, electrophilic substitution reactions are supposed to proceed via the following steps: either generation of electrophile or two formation of carbocation intermediate, or either by removal of proton from the carbocation intermediate. So if all these statement except 2 is correct. It will be 1, 3, and 4. Correct option will be option A. 1, 3, and 4 means A is the correct answer for question number 920. I hope it's clear up till now. Now let's see question number 21. Two organic compounds A and B, both containing only carbon and hydrogen, on quantitative analysis gave the same percentage composition by weight. Carbon equals to 12 by 13 into 100%. Hydrogen equals to 1 by 13 into 100%. And A decolorizes bromine water, but B does not. A and B respectively are. You have to find out which is A, which is B. So you have to determine the empirical formula of the two compounds. You know, empirical formula is the simplest formula. It is derived from molecular formula. Now, the empirical formula of the two compound can be derived in such a way. Carbon is to hydrogen is equal to 12 with respect to 13, because I'm about to find the mass of carbon. And 13 is the sum of this. Atomic mass of carbon is 12, hydrogen is 1, so 12 plus 1 is 13. The percentage of carbon into hydrogen has atomic mass 1, so 100 into 100. The ratio when you calculate this 12 by 13, so the ratio will come to be approximately 90 something, 92 is to 100 by 100 is, I have done here a mistake. The total atomic mass is not 100, it is 13. So what is 100 divided by 13? Roughly 7.67. So let us take 7.7, 92.3, which is again equals to 92.3. This is for carbon, so divide by carbon atomic mass. 7.7, let us divide this by atomic mass of hydrogen. So now you will get the simplest formula. 7.7 is to 7.7. 1 is to 1. Since it is 1 is to 1, the empirical formula is CH. Thus, the molecular formula of A and B will be the simple multiple of CH. So you have many options, either C2H2, C3H3, C4H4, C6H6, C5H5, etc. But from the available options, you have to find out the correct combination. So multiple means C2H2, C6H6, right? These are correct answer for question number 21. Okay, B is also correct. There's two correct answer. Let's say question number 22. The major product of the following reaction. See, when this reaction take place, it's interesting to note that this alkyl part from Grignard reagent will now pair up with this hydrogen and it will leave as alkene. Okay, thereby giving you this intermediate CH3. The leftover part will be, let's write here, CH3. Actually, this is a triple bond because carbon is tetravalent. You have to satisfy the octet rule. CH3C double bond. You have triple bond. Magnesium chloride. You have to link this two. And you know the product already formed earlier was ethane plus CH3, CH3. So now when you treat this again with this heterocyclic ring, it now gives you an alcohol. OHC, triple bond C, CH3. Here, bond breaking start take place. So from this available option, I think C is the correct answer for this. Not C. D will be the answer for this question. Question number 23. 2,3-dimethyl-2-butene can be prepared by heating which of the following compounds with a strong acid. So this particular given molecule, which is C, 2,3-dimethyl-but, let us draw the structure for this Otherwise, we cannot code out the answer. CH3, CH double bond, CH2. Let us do the counting. How many carbons are present? 1, 2, 3, 4, 5, 6, 7. It has 7 carbon. Alright. So from this structure, when it is made to react with a strong acid, it gives hydrogen. This becomes electrophile. Now when this reacts with this double bond, there will be a formation of carbocation, CH3, CH3, CH, then CH3. Now this bond will migrate here. This is a secondary carbocation. And rearrangement will take place. Alright. Rearrangement will take place. This carbon gives it bond here. There you have the rearrangement structure. CH, another CH3, and one more hydrogen. This hydrogen is in excess of the bond. Now you have to give back the carbon and it will form a alkene double bond. Hydrogen will be the leaving group here. So CH3, you can name this. This will be 2,3-dimethyl 2-butene. Okay, so by looking and comparing, the answer will be option B. Because this is the most stable carbocation. Tertiary carbocation is the most stable carbocation. Question number 24. Which carbon atom is the most electronegative in this structure? I hope it is 1, because as the number of bonds between between the carbon atoms increase, electronegativity of that carbon also increases due to the increasing active power of electrons. And this is an sp hybridized carbon. See, this structure 1 carbon, this is sp hybridized carbon, and this is more electronegative than sp2, then more electronegative than sp3, because as character decreases, more is the electronegativity, and hence option A is the correct answer for question 24. 25. Which of the following will have least hindered rotation around carbon-carbon bond? So ethylene, when you look at the options, it has a restricted rotation because it has multiple bond. Acetylene has no rotation. Hexachloroethane has more rotation than ethylene, but less than ethane because of greater size of the substituent chlorine in hexachloroethane than that in the case of ethane, because it is substituent is the present substituent is hydrogen. So if you can logically arrive to the conclusion, the answer for this question, which of the following will have least hindered rotation around carbon-carbon bond? It is ethylene because it has a restricted rotation. That's the bottom line. Question number 25 is C. Sorry, B. The answer for 25 will be B. Match the column. Question number 26. Alkyl plus acid halide in the presence of dry ether. Arene plus acid halide in the presence of aluminum chloride. And also column 2, you have sulfonation, Wurth reaction. The screen size is limited. I will move on to the next page. C. Arene plus fuming sulfuric acid in the presence of aluminum chloride. D. Arene plus hydrogen in the presence of nickel. Okay, column 2, you have 3 catalytic hydrogenation and Friedel-Crafts reaction. So question number 26, you have to pair this. Let's see. A. Okay, this is 2. If you look at the options, and B will be arene plus acid halide. B will be Friedel-Crafts reaction. C. Fuming sulfuric acid in the presence of aluminum chloride. This is your sulfonation. And D. Arene plus hydrogen in the presence of nickel must be catalytic hydrogenation. So from the previous slide, you have A2 and B will be 4, A2, B4, C will be 1, sulfonation, D will be 3. So A2, B4, C1, D3. And for this answer, A2, B4, okay, D. You have D as the correct answer for question number. Right. Question number 26. Let's move to question number 27. Of the three isomeric hydrocarbon given by the formula C3H4, below how many can exist with all the carbon and hydrogen nuclei located in a single plane? So in this hydrocarbon, you are given the formula C3H4. Learn to draw the structure of C3H4. You can count the carbon, 3 carbon and only 4 hydrogen, means you have to manipulate and write the formula. Yes. Now you have the formula C3H4. Hybridization of the carbon atom is sp2 and sp is also present. The molecule is monoplanar. It is a monoplanar structure, but hydrogen atoms lie in different planes. Okay, so the answer for this will be 0. There are 0 hydrocarbon which can exist with all carbon and hydrocarbon nuclei located in the single plane. Question number 28. Excess of acetic acid is reacted with alkyne ethyne in the presence of mercuric salt. The product is. So from the given substrate, CH triple bond CH, react this with acetic acid and mercuric salt. So now what happens here? This product will be formed initially, subsequently add acetic acid. The final product will be this. Okay, so the answer for question 28 will be, you have to find this formula, option A. 29. Which of the following contain isopropyl group? Write down all the structure and find isopropyl group. So you know the structure of isopropyl. So if you write the structure of this 2,4-dimethylhexone, there is no hexane, it's hexane, okay? CH3, CH3, CH2, CH3, CH2, CH3. So this is your 2,4-dimethylhexane. You see the isopropyl group is present here. This is the isopropyl group. So 29 will be B. 30. 1-pentyne reacts with mercuric salt in the presence of acid. It gives X. So what is this X? X in the given compound, 1-pentyne. You can generate the formula here. 1, 2, 3, 4. 1, 2, 3, 4, 5. This is 1-pentyne. So when this 1-pentyne is react with, is made to react with sulfuric acid and mercuric sulfate, the product may be this. Okay. And when it further treats with Y, this BF3, THF, and hydrogen peroxide, it gives Y. So Y may be, I'll write the structure here, CH3, CH2, 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 CHO. X will give positive iodoform test and Y will give positive mirror test. So it can be distinguished by silver mirror and both iodoform test. So B is the answer for question number 30. The major product obtained in the photocatalyzed bromination of 2-methylbutane is. The order of substitution in different alkanes will follow tertiary, secondary, primary. Okay, tertiary, secondary, and primary. So, bromination of 2-methylbutane mainly gives 2-bromo-2-methylbutane. As you can write the structure here. This is your 2-methylbutane. When this is made to undergo bromination reaction, it gives you two product. Minor product will be this one. How to name this compound? We can name this as 1-bromo-2-methylbutane. This is the minor product. And the major product will be CH3, CH3, Br, CH3. This is 2-bromo-2-methylbutane. This is the major product. 2-bromo-2-methylbutane will be option D. I hope it's clear. Let's see question number 32. Acetylenic hydrogens are acidic because the acidity of acetylene or one alkyne can be explained on the basis of molecular orbital concept theory, and according to which formation of carbon-hydrogen bond in acetylene involves sp hybridized carbon atom. Now, since these s electrons are closer to the nucleus than p electrons, the electrons present in a bond having more s character will be correspondingly more closer to the nucleus. So what happens? Due to the high S character of the carbon hydrogen bond in the alkyne, which is 50% because sp means 2. Okay, 1 by 2 into 100 gives 50%, right? Now the electrons constituting this bond are more strongly held by the carbon nucleus, that is the acetylenic carbon atom of the sp hybridized orbital, acting as more electronegative species than the sp2 and sp3. So it results that hydrogen present on such a carbon atom can be easily removed as a proton. So option number A is the most probable answer for question number 32. A. Now let's see question number 33. Which of the following will be most easily attacked by an electrophile? So phenol, as we all know, it is phenol as well as this toluene. They have electron releasing group. Okay, but in the case of OH group present in phenol, it is more electron releasing due to positive resonance effect. Now, in the case of toluene, the CH3 group in toluene and in the phenol, which is hydrogen hydroxyl group, these are the two reasons why the following will be most easily attacked by an electrophile. So compare that phenol and toluene. I'll repeat again. In the case of phenol, and in the case of toluene, both have electron releasing group. However, OH group in phenol is more electron releasing due to plus R than CH3 group in toluene. So in the case of CH3 you have plus I, in the case of phenol you have plus R. That distinguishes why your phenol is more reactive than toluene. So I hope it's clear. Question number 33 gives C as the answer because of plus R effect on phenol, then plus I effect on toluene. Question number 34. Name the following reactions. This is Diels-Alder reaction. This reaction involves cycloaddition between a conjugated diene and a substituted alkene. Okay. This reaction is called Diels-Alder reaction. Question number 35. The most suitable catalyst for the hydrogenation of 2-hexene to 2-cis-hexene is, see, it is a reduction of alkynes with Lindlar's catalyst, that is poisoning of palladium with barium sulfate. It gives cis alkenes. So option A will be the answer for this question. Palladium and barium sulfate. Question number 36. You have to find the major product here. Question number 36. So in this case, in this particular compound, you have three active hydrogen. One attached to the sp hybridized carbon atom and two attached to nitrogen. Hence, this ethyl magnesium bromide Grignard reagent will give 3 moles of C2H6 ethane. 3 is the, okay, B is the answer for question 36. Question number 37. I hope you're keeping up with me. We're about to be done. Okay. Among the following compounds, 1 to 3, the correct order of reactivity with an electrophile is. So it is decided based on the presence or absence of electron releasing group. In the case of CH3, you have methoxy group. It is more electron releasing than that of benzene. Now you have electron withdrawing group in nitrobenzene. So combination of this, option C, that is 1, 2, 3 will be the answer. Clear? Question number 38. What is the major product expected from the following reactions? So formation of a species to be more favorable is decided, and the stability is decided by the order of carbocation. That is, tertiary is more stable than secondary, than primary, right? So from this you can generate CH3. This will come here and it forms carbocation D. As I've told you, tertiary is more stable than secondary than primary. Now the carbocation form is sp2 hybridized. Look at this carbon. This is sp2 hybridized carbon. Okay, that is, it is triangular planar in structure. So either the chloride attack from above or below the formation of the plane of the molecule. So there is probability of resultant product that can either behave as you see in option B. So where D is an isotope, the major product will be B. Option B is the answer for question number 38. 39. The product of the reaction given below is. See, NBS is the full form of N-bromosuccinimide. It results into bromination at the allylic and benzylic positions. Okay, so the most stable product, the product of the given reaction is given below X. Okay, let us see. These are the options given to you. So according to the question, you can expand. So this is the reactant. NBS in light, right? So which will be the most stable product? The most stable product will be this one. And when it is treated with NBS, N-bromosuccinimide, it forms this product. Now again react with water and potassium carbonate. Final product will be an alcohol. Okay, so 39 will be D. See, it resembles D. Question number 40. So this is about ozonolysis. When this reactant is made to undergo ozonolysis, CH3C, you can name this. This is butane undergoing ozonolysis, forms ozonide, right? And after reacting with zinc and water, zinc hydrolysis takes place and it will form a diketone and a zinc oxide. Now the in the above reaction X is, you have to sort out what is X. It is ozone. Okay, you're not asked to find the product. Simple question. Let's move on to question number 41. Which of the following represents the correct order of acidic strength? See, the following represent the correct order of acidic strength, right? You're given alkyne, alkenes, and alkanes, ethyne, ethene, and ethane. The correct order of acidic strength. It is due to the maximum percentage of S character, that is 50% in sp. The sp hybridized orbitals of carbon atoms in ethyne molecule have highest electronegativity. So one must be the highest, right? And ethene and ethane. Clear? And another case, the shared electron pair of carbon-hydrogen bond of ethyne is to a greater extent than that of the sp2 hybridized orbitals of carbon in ethene. And in ethane, you have sp3 hybridized. Thus, in ethyne, hydrogen atoms can be liberated as proton more easily as compared to ethene and ethyne. So you have 1 correct, 4. This is another correct option. So C will be the answer for question 41. Right? Let's see question number 42. Which one of the following compounds have the highest heat of hydrogenation? The heat of hydrogenation of alkene depends upon its stability. You have to mark that point, keep it in mind. Higher the stability, lower the heat of hydrogenation. I'll repeat, higher the stability, lower is the heat of hydrogenation. And since ethene has no substituent, it is the least stable alkene and hence it has the highest heat of hydrogenation. I hope it's clear. So 42 answer will be A. Let's move on to question number 43. On mixing a certain alkane with chlorine and irradiating it with ultraviolet light, it forms only monochloroalkane. Very easy question. This alkane could be, see, in the neopentane, all the hydrogen atoms are same primary. You know why? You can draw the structure and identify all these hydrogens will be same, right? Because these hydrogens are primary. So neopentane will be the answer because on mixing a certain alkane with chlorine and radiating with ultraviolet light, it forms monochloroalkane because the hydrogen atoms are all same. Question number 44. Acetylene gives, acetylene is alkyne, ethyne, the first alkyne. Acetylene gives which of the following result? Okay, on addition with copper chloride, let us see. Acetylene, Cu2, Cl2. When this acetylene reacts with copper chloride, it gives red color, copper acetylide. That is CH See, because on the SRP values, when you look hydrogen, mercury, silver, it can replace this. Okay, copper, this is a salt. And further, if you react this with silver nitrate, the product will be CHC. Both are salt, and the above reaction form basis of test to distinguish between terminal and non-terminal alkynes. So A is the answer. It gives white PPT with silver nitrate, red with copper chloride. You can say cuprous chloride. Last question 45. sodium ethoxide is a specific reagent for? Okay, this is left for you to do. The last question. You can give the answer in the comment section. We'll see in the next episode. Thank you.